Now let's answer one more question. What are the number of possible matrices of order 3 cross 3 with each entry 0 and 1? Now we have to find the number of 3 cross 3 matrix such that each of the place can filled either by 0 or 1. So in order to solve this question, first let us make 3 cross 3 matrix. So this is a 3 cross 3 matrix. That means in 3 cross 3 matrix we need 3 rows. So this is first row, this is second row, and this is third row. And we need 3 columns. So this one is first column, and this one is second column, and this one is third column. So we have 3 rows and 3 columns. So what are the total number of elements in this matrix? They are 9. If we count them, 3, 3, 6, 3, 9. There are total of 9 elements. So we can multiply 3 with 3, we get the 9 elements. Now, each place is to be filled either by 0 or by 1. So that means each place can be filled in 2 ways. So these are 9 places. Since each place is to be filled by 2 ways, so total number of ways of filling these places will be 2 to the power 9. Because 2 into 2 into 2 till 9 will make 2 power 9. So the total will be 512. So if we have to make 3 cross 3 matrices with any of the 2 numbers, so the total number of matrices come out to be 512. So now, if you are asked to construct 2 into 3 matrix such that Aij is equal to 3i plus 4j. Now we have to construct a 2 cross 3 matrix, that is a matrix having 2 rows and 3 columns, where the relation of each element is given by Aij is equal to 3i plus 4j. So that means कि every element present in 2 cross 3 matrix will be related to this relation. Now first of all, let us make 2 cross 3 matrix. Now 2 cross 3, so we need 2 rows and 3 columns. So this is first row and this is second row. These are the 2 rows and now 3 columns. 3 columns, 2 and 3. So we have 2 rows and 3 columns. So this is written as A11, first row, first column. This is first row, second column, and this position is first row, third column. Similarly, this position is second row, first column. This is second row, second column, and this is second row, third column. Now since Aij is equal to 2i plus, it is 3i plus 4j. So what is A11? It is 3 into 1 plus 4 into 1, which is 7. And what is A12? Now here I is 1 and j is 2. Put I1 and j 2. So this becomes 11. A13. So A is 1 and j is 3. So this is 15. A21. So it is 3. I put I2 and j1. So it is 10. And A22. That means put I2 and j2. So this becomes 14. And we have to find A23. So it will be 3 into 2 plus 4 into 3. It is 18. Now we put all these values here. Now A11 will be, A11 is 7, A12 is 11, A13 is 15, and A21 is 10, it is 14, and it is 18. So this is a matrix of order 2 cross 3 where we have to take Aij is equal to this. Now let's do one more question of the same type. You have to construct 3 cross 3 matrix where Aij is equal to 2i minus j mod. Or we write 2i minus j square, 2i minus j square mod. So let's construct 3 cross 3 matrix. So we need 3 rows and 3 columns. So now we need 3 columns. So this is first column, this is second column, and this is third column. Now we need 3 rows also. So second row is A21, A22, A23, and the third row is A31, A32, A33. So this matrix is 3 cross 3. Now similarly, now we directly put the values. What is A11? So here Aij relation is this. Now A11 हमने निकालना है तो I को हम 1 लेंगे, J को 1 लेंगे, यहाँ पुट करेंगे 2 into 1 is 2 minus 1 square. 2 minus 1 is how much? It is 1. So this is 1. A12 I को हमने 1 पुट किया और J को हमने 2 पुट किया. 2 minus 4 it is minus 2, but it is in mod, so it becomes 2. Now what is A13? So 2 minus 9. 2 minus 9 is minus 7. इसका mod है तो it becomes 7. So similarly 2, 1. तो यहाँ पे 4. 4 minus 1 is 5. 4 minus 1 is 3. Then I को 2 put करेंगे 4 and J को भी 2 put करेंगे. It comes out to be 4 and it is 0. Now 4, 2, 3. I2 that is 4. 4 minus 9. It is minus 5. Then it is mod is there. Therefore it is 5. So it is 3, 6. 6 minus 1. It is 5. Now 6 minus 4. 3, 2. 6 minus 4. It is 2. And 3, 3. Now I 3, 6. And J is 3, 9. 6 minus 9 minus 3. It is in mod bracket. So it is positive 3. So this is a 3 cross 3 matrix where Aij is given by this. So similarly, you can find any of the matrix if the relation is given to you.